Hello everyone, Assalamu alaikum. Now I am starting with the seventh lecture on the topic of thanatology in the series of my forensic lectures. The objective of my lectures is basically to impart basic knowledge of forensic medicine, basics of forensic medicine, which are important for students and young doctors which are involved in the medical legal work. So in this upcoming lecture, seventh lecture of thanatology, we'll start with the early changes, which appear after some time after death. And as we know, these changes are the contact flattening, cooling of the body, post-mortem staining, and rigor mortis. So we'll discuss these changes, and in this lecture, we'll discuss contact flattening in detail, how it appears. Then we'll discuss the cooling of the body, how the human body cools after death, and how the cooling progresses, and why the human body does not behave like a metallic object in a reference to cooling, and what are various methods to measure this cooling progression. And as it helps us in determining time since death, sometimes this becomes an important parameter. So gadget what type of thermometer is used to estimate the temperature, to find out the temperature of the dead body when it is received, and that is compared with the environmental temperature. And there are certain formulas upon the basis of which we can determine time since death. So we'll discuss these changes in this lecture. Take care. Allah Hafiz. Hello, Assalamu alaikum. Bismillahir Rahmanir Rahim. And now I'm going to start the seventh lecture on the topic of thanatology. The learning objectives of this lecture will be that by the end of this lecture, we will be able to understand what are the early changes which appear after death. And we'll discuss these early changes. And as we know that these changes are contact flattening, cooling of the dead body, post-mortem staining, rigor mortis, and these early changes we'll discuss one by one in the upcoming lectures. The contact flattening we'll discuss in detail, and we'll see how it develops, what phenomena is occurring to cause contact flattening. Then we'll start with the topic of cooling of the body, and this will be our objective, that how the body cools after death, and we'll try to understand that how the human body behaves in the reference to cooling, because we'll learn that the human body does not behave like a metallic object, as it is not a homogeneous structure like a metal. So it behaves differently. We try to learn that how it happens. Then we learn how the cooling how it progresses, because this body has now going to attain the environmental temperature and lose its heat, because there is no heat production, and it will attain the environmental temperature. And how it progresses, we'll learn that. Then we'll discuss how to measure this falling temperature, what are the gadgets which are used, and what that thermometer is called, and how we will measure it. And there are certain formulas which help us in determining time since death. We study the body temperature, the environmental temperature, and apply certain formulae, and that helps us in estimation time since death. So starting with the lecture, the early changes. And as we know, the early changes are contact flattening, cooling of the body or Elgar mortis, post-mortem staining, also called as liver mortis, and rigor mortis, that is post-mortem stiffening. So we'll start with the first earliest change which appear in early hours, that is contact flattening. The word itself is telling that flattening is occurring because of contact. The body flattens over the areas on which they are in contact with the surface on which it is lying. As normally the body is supine, face is upward. So those areas which are at the back, they are in contact with the surface on which the body is lying, and they will be flattened. And this is because of the loss of muscle tone, which allows those parts of the body which are subjected to pressure by the weight of the body to become flattened, because there is no tone in the muscle and the weight of the body is pressing down. So those areas which are in contact with the surface on which it is lying, they will become flattened. So when the body is lying supine, that is face is upward, the flattening will be seen over back of the head, shoulder blades, buttocks, and the calves, because and heels terminally. And these are the areas which on the posterior surface of the body are in contact with the surface on which they are lying. So on appearance hypostasis, that is post-mortem staining, these changes will be more readily marked, because these area are pressure points, they will be pale, and in between, as their areas which are not in contact, there will be hypostasis, though the pressure point areas, they will be pale, and the other areas which are not in contact and the body has gravitated in those regions because of hypostasis, postmortem staining, then the contact flattening areas will be more prominent. That's all. You can see this is a model showing the back of the chest, the back of the buttocks. They have been flattened, but the other areas which are not in contact, they are of either normal color of skin and the blood has pooled because of postmortem staining. This is another picture of the body showing the back, the contact on the back of the chest and the buttocks. Now we'll start with the cooling of the body, that is also called as Elgar mortis. Cooling of the body, which is the early change after death. And this is also early sign, called as early sign. The cooling of the body, the Elgar mortis, as normally we know the physiology that during life there is a balance of temperature by the heat production and heat loss. Metabolism is going on, the heat regulatory center and other physiological phenomena are going on. So there is a balance and body temperature is maintained at the temperature which has been fixed by the nature. So the heat loss and heat gain will be proportional to maintain the body temperature. And after that, as we know, there is no heat production and only there is heat loss. So the body will start losing its heat and the heat loss will be gradually going on and the body will be attaining the environmental temperature. There are three main ways by which the human body normally loses heat. That is radiation, convection, and conduction. And conduction is not an important factor during life because the body is moving, because body is upright, only feet are touching the ground, or when you are sitting, the back up, the buttocks and the thighs are touching. But after that, the whole body is in contact with the surface on which it is lying. If it is lying on the ground or any other surface, the back of the body, the head, back of chest, abdomen, buttocks, all they are in contact. So in this condition after death, conduction becomes the most important factor. So the most of the heat is lost by conduction, which is a considerable factor after death. So disappearance of body warmth is one of the earliest signs of death. Low body temperature is a sign of either death or hypothermia. During life, the normal body temperature is 98.6 degree Fahrenheit or 37 degrees Celsius. And body maintains this temperature for some time, and cooling of the inner core of the human body depends upon the loss of heat by conduction through surface and on the surface or layer which is lying. So initially the body maintains temperature. We'll discuss when we'll move on that how the initially temperature is maintained. Human body does not cool in accordance with Newton's law. Newton's law is experiments on objects, metallic objects, but human body does not behave like metallic object. The Newton law states that the rate of loss of heat at any time is directly proportional to the temperature difference between the surface of the object and the surrounding. That means the difference between the body and the environmental temperature. This is the most important factor. So the rate of loss will be directly proportional to the environmental temperature and the body temperature. This Newton's graph is simple type, that is called as exponential type, showing a rapid fall initially followed by a slow progressive fall till the temperature matches the environmental temperature. So this is for the metallic object. Any metallic object shows exponential type of graph. So this is how it appears. Initially for a few hours there is rapid fall, and later on this fall is at lesser rate. So this is important that the human body does not behave like metallic object. Human body does not behave like metallic object because human cadaver is composed of many types of tissues and organs having variable conductivity of heat. The covering fat acts as an insulator and it conducts heat poorly as compared to the other tissues. The body surface cools more rapidly than the core of the body. The central temperature remains unchanged for the first few hours. So always the core temperature should be recorded for the purpose of estimation of time since death. The rate of cooling of the body is generally accepted as most of the dependable criteria for estimating time since death, especially for the first 12 to 18 hours. So how the human body cools, the progression of cooling in human body is the outer layer temperature, which is 2.5 centimeter thick and have heat insulating properties, the skin and subcutaneous tissues. So relatively little cooling of the interior of the body takes place. A is showing, I'll show the curve next. So this is pointing to that point that initially the temperature is maintained because of the insulating layer which is covering the whole body of the humans. At this time, the preservation of the body temperature might be also related to small extent by the chemical changes in the body which are taking place. And what are those changes? As the metallic process is going on, normally when the person is alive, the metabolic process, they are going on aerobically, that oxygen is present. But there is anaerobic glycogenolysis. The glycogen contents are within the muscles, and the anaerobic glycogenolysis, that is metabolism which is going on anaerobically, is going on. And for a short time, this anaerobically process produces heat, and it constitutes another factor which contributes to maintain the initial temperature, which is the initial plateau of the graph which we will develop. So on the one end, the outer layer, skin and subcutaneous tissue, they are having the insulating factor. And secondly, because of anaerobic glycogenolysis, anaerobic metabolism, which is going on within the body, that is contributing heat. And that's how the body maintains heat for a certain period of time after death. So this is known as the post-mortem anaerobic glycogenolysis, and it can produce approximately 140 calories, which is sufficient to raise the body temperature 2 to 3.6 2 degrees Celsius or 3.6 degree Fahrenheit for the initial 3 to 4 hours after death. So they can maintain temperature, they can raise the temperature to up to this level. So this is another factor, anaerobic glycogenolysis, which is imparting heat to the body. Insulating factor and anaerobic glycogenolysis. So this is why the human body does not behave like a metallic object. Metallic object is inanimate, dead, no metabolic processes going on, homogeneous structure of some material. So it is directly proportionately releasing heat to the environmental temperature. So human body does not behave like metallic object, as it is on the one side composed of various materials, the fat, the muscles, the bones having different conducting and insulating properties, and there are insulating factors of the outer covering and anaerobic glycogenolysis. So these factors play an important part that why the human body does not behave like metallic object. So this is showing the part of the next curve that in next 6 to 9 hours, as the skin temperature falls, as there is gradient has been established from the body and the environment, the interior of the body will also rapidly fall. And beyond 12 hours after death, the temperature of the skin is approaching to the environmental temperature, then the loss of heat will be slow. So this will be the C part of the graph which I am showing you. So initial A part, in which the body maintains its temperature by the insulating covering, anaerobic glycogenolysis. So initially the part A of the curve shows the body maintains its temperature, and part B of the curve, that when the gradient has been established, the body starts losing its heat. And after 12 hours, this loss will be slower because the body has been now approaching the environmental temperature and the loss will be at lower pace. Then how will measure the temperature in a dead body? The clinical thermometers or measurements are usually taken with the help of clinical thermometer, which are put in the mouth or in axilla or in other regions for recording the temperatures. But at autopsy, the temperature of the dead body is measured by taking the rectal temperature. Because the person is not alive, he cannot open his mouth. So the temperature is recorded from the rectum. That is, the rectal temperature is recorded. Normally, the rectal temperature is the best. It is approximately 1 degree Celsius higher than the temperature which is recorded from the mouth. This is the talking about the living object. But the subhepatic and vaginal temperatures can also be taken, especially when there are other precautions which are taken, which prohibits the recording of temperature from the rectum. So a special thermometer which has been marked from 0 to 50 degree Celsius, which are graduated in degrees, are used to measure post-mortem temperature, and this thermometer is called THANAO-METER. So THANAO-METER has been graduated from 0 to 50 degrees Celsius. So for recording the temperature, the tip of the measuring device, that the THANAO-METER, is inserted for at least 3 to 4 inches into the rectum. It should be left in place for at least 2 to 3 minutes. As the temperature varies from place to place, the thermometer or the THANAO-METER should be inserted at various levels. At least 4 readings are taken at half an hour interval, so to determine the rate of cooling. No matter how accurate the measuring instrument may be or how elaborate the procedure of determining body temperature is, even then the rectal temperature at the time of death can never be known. So the most important thing is, as early as you receive the body, immediately the temperature, rectal temperature, should be recorded and noted down. Environmental temperature and rectal temperature, they should be noted down. But as a routine, this is not possible to record the temperature immediately as the body arrives. So there is always a delay. The police, they bring the body and they request initially for the preservation of the body for 3 days till they fulfill the legal documentation and other requirements. Then they will request for autopsy. So, but this should be, the rectal temperature should be recorded as early as the body received, as early as possible, as I have told you. The important precaution in this regard is, if there is any possibility of some sexual assault, sexual intercourse, whether homosexual or heterosexual, no interference with the clothing or the perineal region should be made until the forensic examination is complete. That is, the rectal or vaginal temperature should not be taken if there is any allegation of sexual assault. No instrument should be inserted into the rectum before trace evidence has been collected, and that is semen, hair, fiber, they are collected. Initially, examination for the sexual assault should be done. In such cases, the subhepatic temperature is recorded, that is an incision in the right hypochondrium is given, and the temperature, the thermometer is placed below the liver, and subhepatic temperature is recorded in that case. Now the methods for calculation of the temperature. The hourly calculation, Newton's formulae, they are usually said as they are unreliable and not applicable. So Newton's formula is based on the average fall, which is, that in Newton has been estimated by applying various formula, that the average fall is equal to 1.5 degrees Celsius per hour. So when you record the temperature and you compare with the normal, how much it has been fallen, so 1.5 degree per hour will give you the estimation of time. So rate of loss of heat is directly proportional to the temperature difference between the surface of the object and the surrounding, and that is the environmental temperature. So the required data for temperature recording is the temperature of the body at the time of death, cause of death should be known, the temperature of the environment, temperature of the seat of the body, that where the body is lying, that is also important to know. So under average circumstances, it has been seen that 1.5 degrees Celsius per hour to plus minus 2 degrees Celsius, keeping in mind the cooling curve. So this is the average estimation which the fall of temperature gives us, help us in estimation. No other criteria are more reliable. It should be least preferred because the other criteria are more reliable. So the temperature sometimes becomes not as important criteria, but it should be. So comparing with all other injuries, we can take the average of all the injuries and all the other changes and can estimate the time since death. So the formally to determine time since death from the cooling of the body, they are Glister and Rentol. They have devised certain formulae, and this is that the 98 minus 6, 98.6 minus the rectal temperature divided by 1.5 gives you the number of hours. This is another formulae. So generally the body cools at a rate of 2 degree Fahrenheit for the first 6 hours and thereby 1 degree Fahrenheit per hour till the environmental temperature. So the various formulae, various methods, various criteria have been devised by various scientists. So this temperature recording in estimation of time since death so becomes not a reliable criteria. So the summary of today's lecture is that we are able to understand after this lecture what are the early changes which appear after death. And as we know that those early changes are contact flattening, cooling of the body, post-mortem staining, rigor mortis. And in this lecture, we have discussed the contact flattening in detail and how it develops, why it develops. Then we have learned the cooling of the body, how the body cools and why the body does not behave like metallic object in reference to cooling. We are able to understand that. And we have learned the cooling progress, how it progresses, body progresses to cool. And we have discussed the various methods to measure the temperature and various formulas which help us in recording the temperature. So in short, this is method temperature recording after death gives us an idea, but it's not as reliable methods as other methods. Thank you very much. That's all. Allah Hafiz.